Good afternoon.
Good afternoon. Hi, y'all. Welcome. Just letting a few of us in. We're still waiting on a few more because we got 11 more coming in. Give me a sec to let everybody in. Welcome, everyone. Good afternoon. I hope you all enjoyed your lunch break with whatever it is that you did for your lunch break. Hopefully ate. If not, feel free to, munch. All right, cool. Let's go ahead and do our check-in just so I could take a look at who's here right now. Oh, we got a few more coming in. All right. Well, welcome. It is November 16th. And yeah. And I just put this picture right here, and I really don't know what this animal thingy is, but yeah. Anteater? I'm not sure. But anyways, here's our attendance check.
I forgot what it's called, but it's a type of bear thingy. Well, it has partial like name bear, and it's like supposed to be a really, really small, like microscopic animal. I'm pretty sure.
Oh, wow. Okay. Awesome. Thank you, Danny. I have no idea. Just looked cute, so I put that in there. All right, so our attendance check, it says, if you could be guaranteed anything in life besides money, what would that be? And this one you could be as open or as close. Ew. Sorry, when you said it looks like a tapeworm, that's yeah, that made me not want that. I'm writing on a tapeworm. All right, and then science says nothing. So if you could be guaranteed anything other than money, what would it be? And this is our attendance check question, so I could double check. A dog that ages like me. That's interesting. Yeah, they have like a short lifespan. Ha ha ha. PS5. Everybody wants that right now. They're like sold out, right? A successful job, guaranteed dream job, right? Or a really good job anywhere. Yeah. All the clothes I want. Now, omniscient. I forget what that means. Omniscient. A good job, yeah. Free Starbucks around the world. That could be cool. And then a lot of us want good jobs. Confidence and self-love. I like that one. That one's less materialistic. Remember, this could be anything. This is an open question. Oh, okay, CJ means knows everything. Thank you. I hope that sticks in my head. Omniscient. I hope I'm saying it right. Juice. Okay. Happiness. Yes, I love that. Just happiness. That's a good one. All right. Any others? The animal is a tardigrades, also known as water bears. All right. So that animal in my the picture right there is a tardigrades. Thank you for sharing. I'm gonna look that up, and I hope it doesn't look like a tapeworm. All
It
right.
looks uglier, but it doesn't look like a tapeworm.
Oh my goodness. Okay, that's funny. All right. So let's see. This is who I have absent, and it's based on the check-in question. So if you didn't answer it, just if you could answer it quick, and it's okay if you're like IDK, that's okay. I'm missing Jalen Baker, Jasmine Beltran, Tori Brown, Denise, Miles Ford, Jirel, Alexander, Carlos, Kyla, Risha, Leon, Ryan, and Celia. That's what I'm missing. I know I'm gonna get more though coming in, but if I said your friend's name, we just got Alexander now. So if I said your friend's name, let them know. Today we got some participation stuff going on, so definitely don't want any absences. Welcome, y'all. So again, let me just repeat who I have absent. It's Jalen, Jasmine Beltran, Tori Brown, Denise, Miles Ford, Jirel, Carlos, Kyla, Risha, Leon, Ryan, and Celia. So that's who I'm missing. If you could please send them a text. I don't want them to miss out. Oh, we just got Miles. Yay. Let me fix this up. All right. Awesome. And I appreciate any help in getting all of us in here. Okay, let's go. So thank you so much. For those who came in, feel free. So if you could be guaranteed anything in life besides money, what would it be? And if it was for me, I think I'd go with happiness as well. For me, it's like, because I don't know. I want to be happy in whatever condition I'm in. Originally, I said a house, but I'm changing it. All right. All right, y'all. So here's our agenda. So we just had our attendance check. We're going to synthesize the big ideas from last week's Desmos, which we had on last Thursday. Remember when y'all did the Desmos and y'all were trying to figure out the connection between a rate graph and an accumulation graph? We're going to finally kind of synthesize that and take away the big ideas, and we're going to take notes. And you want to take notes today because I'm collecting notes today. So that's a heads up. Take notes. There's going to be a Google Classroom submission that you want to submit for that. After we do our Desmos big idea synthesis, we're going to have a Google form. And I color coded this in red so I could show you where I'm grading the participation today. We have our Google form, and we have another one, which is going to be a Google Doc participation. Like, what do we do when we have something called a Kirby rate graph? So we'll take a look at that. I don't think we'll do the group Padlet. We'll see, but if we don't, we're just going to jump into our checkout. All right. Let's see what's in the chat. Um, and then all I want is money, though. And then someone said Le Grasp. I'm not sure what that means. All right, we got Jasmine B and we got Tori. Yay, we're getting more of us in. Welcome, everybody. We just came in. Let me just fix up our attendance. And we got Ryan. Yay. So happy. So let me see. We got Jasmine B, we got Tori, and we got Ryan. Welcome, y'all. Oh, and here's Kyla. All right. All right, so asynchronous number 9 was due yesterday. As y'all remember, my due dates for async work is Tuesday, Thursday, and Sunday. And one was due yesterday. I did send an email to y'all just like to get y'all to turn it in. Asynchronous number 9 is basically based on attempt. You don't have to be right. Literally just try it out, submit it, you get your credit. So I want to definitely encourage y'all, if you haven't yet, to get that in because I haven't yet graded it. I'm going to grade them tomorrow morning. Async number 10, however, is posted. That one's due tomorrow at midnight. So that's just as a double check. All right. So for those who just came in, y'all, heads up. Today we do have notes collection. please make sure you're taking notes. Get some binder paper or get a Google Doc if you're trying to take electronic notes. We're going to be taking notes today and it will be collected after class. I want to just make sure I repeat that because I always say it, but then at the end we're like, wait, we're taking notes. All right, and I got you, Tori, you're here.
Are we taking notes of this recap or no?
No, don't worry.
Okay.
Recap, no. I'll let y'all know when to start. But I'm also putting it into the chat, so I just double emphasize today we are collecting the notes. So this is a recap. So this is what we did last time right here. You're not taking notes. Don't worry about this part. So recap from last week. So on Thursday, we had this Desmos activity where you all tried to investigate the relation between this rate graph and its accumulation graph. They're basically recording the same data, but they're represented in a different way. One is a rate and one's an accumulation. I also reminded you all that we know that this is a rate because a rate always has per. Like remember when we did beats per minute? That's a rate. This right here is speed, miles per hour. So you would write it like this, miles per hour. That means that's a rate. Whenever you have like the per, that division sign, that gives it a rate. Accumulation, something is getting accumulated or added on, just like there. Distance. Distance was increasing even though your rate was constant. So you all did some investigations on that in your group, and your learning target was to investigate that both independently and in your group. Let me go ahead and clear this. Again, you're not taking notes on this slide. And then here, again, you're not taking notes. I'm just reminding you about, these were the essential questions you all had to work with on Desmos. You were asked, how is the accumulation graph related to the corresponding rate graph? And you were asked to answer, how does each graph verify each other? That was on Desmos last week. And here's a sample graph that I took, a poster. One of your groups did this, and I wanted to point out like something I noticed like after class that y'all exited. Like I noticed that they kind of, this group right here kind of did division. Like this group noticed that 50 divided by 1 is 50. And then 100 divided by 2 is also 50. And then look here, 150 divided by 3 is also 50, which corresponds to this constant 50 right here. So I just noticed this. I don't know which group this was. Feel free to shout yourselves out, but that's a pattern that they noticed. When they divided the distance over time, they got the rate. So that was new. Another reminder I wanted to remind you all was this. So this was the fake name. This is from actual someone's name, but I don't want to call anybody out. One thing that you all noticed was when you, to get the total distance from a rate graph, all they had to do was 3 times 50. So if you see the 3 right here, 3 times 50 gives you 150, which is the total accumulation after 3 hours. That was another thing that was written in the responses down here. And then I kind of at the end of class, like last time, pointed out that 3 times 50 is actually like the area of this here rectangle. I'm just shading it in. Wow, and I chose gray to shade this. Not a nice color, but I wanted to use yellow. But y'all know what it means. So the area of this shaded part right here, gray shaded part, the area of this rectangle here would be equivalent to 3 times 50, which is 150 miles. So there's that correlation right there. So this part, again, you don't have to write down because we're going to synthesize that in a second. This right now is for y'all to just pay attention to what the work y'all did last week and what you're supposed to kind of investigate from there. So those were the relations. Now let's get on to the part that you definitely want to write down. So let me clear this up. All right, so here's where you want to start writing down your notes. The big ideas. So these are like what's supposed to come out of it and what were the big ideas. So number 1, you want to write this down. So here's a big idea and it's huge because we're going to be using this throughout the unit. The total area under a rate graph. Rate means this one, rate graph, the area, which was like that part I highlighted. Under the rate graph approximates the total accumulation, i.e. distance in this case, because when you multiply the height of the rectangle times the base, you get the total distance. So this one you want to copy down. And this time I'm going to correctly shade this yellow.
Do we have a title?
Yeah, big ideas from the Desmos activity. I don't know if you're able to see it. So this right now is the big ideas from the Desmos activity. And what I'm doing right now is I'm trying to shade the area under the rate graph, just like I did before, but now I'm doing this in yellow, so it's easier to see. So the area of a rectangle, y'all, if you remember from geometry and or like any other time you found the area of a rectangle, you know that the area of the rectangle is base times height or height times base, however you want to look at it. So, and this you want to definitely copy down. You want to shade in like this rectangle. So the height of this rectangle is 50 miles per hour. That's the total height. The base width of this rectangle is 3 hours. 3 hours. When you multiply 50 miles per hour times 3, when you do that multiplication to get the area, times 3, the area is equivalent to the total distance slash total accumulation, because anything could be accumulated. In this case, it's distance. The area under the rate graph gives us the total accumulation. So this, my drawing right here is connected to this first big idea. Yes, this is the notes. This is where you want to take notes. And you definitely want to do the little, the coloring in and stuff that I'm showing you all. All right, next big idea is also super important because it's going to make more sense as to why the area under the curve actually gives you, or the area under the line, under a rate graph specifically, actually gives you the total accumulation. And this is the why. Anytime you have rate times time, it gives you accumulated unit. So let me give you the same example right here. So 50 miles per hour, that's rate. 50 miles per hour, that's your rate. See, that's rate right here. And I'm going to multiply that by the total time. And I think we counted 3 hours down here. 3 hours. And I multiply rate, this is my rate, times time, I get the total accumulation, like what's getting added up. And the reason for that is because something cancels out here. The hours cancel out. When the hours cancel out, all you're left over with is the accumulated unit, which is miles. 50 times 3 is 150 miles. So that's the why. That's like the why, the units cancellation there. Why does the area under the curve give me total accumulation? Here's the mathematical reasoning for that. Let's see, there's stuff in the chat. Sorry. Someone said, wait, give me a sec. That's okay. I'm gonna keep this slide up. Okay, and then someone said they're gonna join with a different computer. No problem. All right, that says 150, by the way. All right, let me pause here to see if anyone has any questions so far about the big ideas and what I'm talking about, area under a rate graph, giving us total accumulation. Again, pay attention to where that 150 is coming up. It's right here. After 3 hours, we traveled a total of 150 miles. All right, and then there is one more, and it kind of relates to the poster that was shown before. Well, we talked right now, these first 2 bullet points I think basically talks about how the rate graph corresponds to accumulation. So I feel like we strongly talk about this, like how this rate graph relates to this. The area under the rate graph gives me accumulation, but what does accumulation tell me about rate? Well, for that one, I would totally steal the idea that was in that first poster I showed you all. It was the group poster you all made. They were dividing. They were dividing, saying like, oh, this divided by this gave me 50. This divided by that gave me 50. There we go. So the thing they were doing is actually they were finding the slope. This is the third big idea. The slope of the accumulation graph is the constant rate of the rate graph. Let me write that down right here on the side. So the slope, that's rise. The rise is 150 miles. That's I'm doing rise over run. So let me write that down. Rise, that's slope, rise over run. The slope of this accumulation. See, my rise is 150. It's going up by 150, and it's going to the side 3 hours. So my rise is 150 divided by my run is 3 hours. And if we divide that up, what we get is your rate, which 150 divided by 3 is 50 miles per hour, which is the rate. That's huge. The slope of the accumulation graph gives us the rate. So that's how we could connect how accumulation is related to rate. I'm going to put slope. And over here it's area. The area under the rate graph gives me accumulation, and the slope of the accumulation gives me the rate. See how all that's connected? So this is super important. Let me just pause here, maybe 45 seconds. I hope y'all were copying this down as I was talking though. Slides are on Google Classroom, but not my notes on it right here on the side. So I'm gonna pause here. And someone asked, do I draw the graph? Yeah, I strongly recommend it. I'm also going to continue the notes. We're gonna have more examples of rates and accumulation for y'all to take notes on too. So yes, I do recommend drawing the graphs and like the arrows and how they're connected. And by the way, y'all, please pay attention to the big idea synthesis because we're gonna also have an exit ticket based on your understanding about this right here. So basically today is understanding the concept, not really much about doing technical math parts today. Yeah, was there someone trying to talk? Sorry.
Yeah, what is the R times T again?
R times T is rate times time, and it's also right here.
Oh, okay.
Rate times time equals accumulated unit. All right, and like I said, I'm gonna pause here. Y'all can get this down or get any questions out there, and then we're gonna do more examples too before our little Google form. All right, a few more seconds, and then we're going to go on to some more examples because I want to show you more examples that's not just about speed and distance. There's actually more than just that when you're talking about rate and accumulation. So let me go ahead and clear this slide. And again, if anyone needs a copy of this, I could send you all the video. It does take like an hour to upload. That's why I usually send it a little later. Let me go ahead and clear the drawings. And we're going to move on to the next example. Here's another one. And yes, you want to copy this down. So right here, what we have is another example of a rate graph and an accumulation graph. And this right here, notice it says pay rate graph. This is like if you're working at a store or something and your pay rate is the dollars per hour you get. this one, it's kind of hard to see, like, well, how much dollars per hour am I getting? So if it's hard to estimate, you could also look at the table. It looks like you're getting about $13 an hour, looking at the table right here. So because you're getting a constant $13 an hour, your pay rate is a straight horizontal line. It's not changing. You get a raise, right? You're just going to get constantly $13 an hour. So that's why the pay rate graph in this example is straight. It's like a horizontal straight line. But just because your pay rate is constant does not mean you're not getting paid, right? You're just constantly being paid the same amount. So that's why if you look at your accumulation graph, your line is going up because the amount of dollars in your pocket is increasing. Pay rate is constant, but money is still getting accumulated. So just make sure you sketch this out. And then I'm going to also make the connections to the big ideas as y'all are sketching this out. So one of the big ideas is that the area under the rate graph gives me accumulation. So I'm going to go ahead and test this out for, let's say, the first 2 hours. Right here it's 5 hours, so 2 hours must be right here. And when I say area, wow, it's gray again. Anyways, so when I say area under the curve, when you shade your area, you always stop at the x-axis. So notice I just drew a rectangle and I don't go below the x-axis, I stop. This is what we mean when we say area under a rate graph. So I went ahead and I colored that for the first 2 hours. Like, okay, let's verify if that's true. Like, is it true that this area after 2 hours is going to correlate to how much money I get in the accumulation graph? So let's see, my height of this here rectangle is going to be $13 an hour. So I'm going to put 13. I'm going to just do a dollar symbol. Dollars an hour. See how this is another kind of rate graph. And my base is, of course, just 2 hours. In order to find the area of this rectangle, I'm going to do the height times base, or rate times time, right? To connect to our big ideas. So we know that rate times time equals accumulated unit. That's our big idea. Accumulated unit. So we're just going to now verify it with this pay rate graph. I'm just going to do a cum unit. And we could cross out to see what is the accumulated unit. So my rate, $13 an hour. $13 an hour times the time, and we said 2 hours. And let's see in the chat, when I do this rate times time multiplication, what units are canceling out? Let's see if anyone in the chat knows from earlier. What's going to cancel out if I multiply $13 per hour times 2 hours? Something should cancel out.
Hours?
Yes, hours. Thank you. Hours cancels out. So then what we get is 13 times 2. That's going to be $26 because dollars was left over. So that's our accumulated unit in this scenario. Rate times time gives me the thing that's getting accumulated. In this case, it's money. So let's verify, is that true? So if I go to my accumulation graph, after 2 hours, do I indeed get $26? So if I trace up my accumulation graph, that line there's 25. So I think, yeah, it's about right. Oops. We do get a total of about $26. Or you could check out your table, which is here. After 2 hours, you get $26. So right now I just used a different kind of rate graph to show you that the area under this pay rate graph is equal to the total accumulation, or the total money you get in this case. And so again, remember the area gives me accumulation. So if I find the area of the rectangle, I get the total accumulation. And then remember to go back you do the slope. Slope is rise over run. So let's do 26 divided by 2. That's rise over run. $26 divided by 2 hours is gonna, again, give me my $13 per hour. 26 divided by 2 is $13 per hour, which is indeed the straight rate graph that's right here. It is indeed that $13 per hour that we're looking at right here. So notice how, again, both of these graphs work with each other. So the area under the rate graph gives me accumulation. The slope of the accumulation gives me the rate. So that's just how these two are related. We're gonna do one more, and then we're gonna have our Google form. Let me know if anyone has any questions on this one, but yes, you wanna copy this down. Notes will be collected at the end of class, so you're gonna have to take a picture and submit it. I'll just pause here.
No, but I can't really keep up.
You can't keep up with the notes?
Yeah, especially with drawing the graphs.
Okay, just do a quick sketch of it, but let me give, I don't know, let me give you all a minute then. I'll increase the time on each slide before I move on. Thank you for letting me know. And then Gabriel did put, are the graphs required too? Yes, but you don't have to be super detailed on the graph. For example, the pay rate graph, just do the, your horizontal straight line. You don't have to do all the little boxes. You know what I mean? Just do a quick sketch. Doesn't have to be perfect, and just do the quick tables. And the annotations would be great, like showing that the area is giving you the accumulation and vice versa would be good to have in your notes. So let me, yeah, I'll try to increase the time on each slide before I move on. All right. I did give you all some extra time on this, but again, I will also send the video to recording. And I won't be like, as long as you get most of the notes down, it's not gonna be so picky where you need to have every single little, just turn in what you took as notes today. Don't be, too stressed about like being perfect on it. And those who are taking your virtual notes, you could totally just take a screenshot and then copy that down as well. So I went ahead and cleared my things so we could talk about the last example before a Google form. Again, this is like 3 examples of different types of rates and accumulation. So far we talked about speed as a rate and distance as accumulation. We talked about pay rate as a rate. And then we talked about the money as accumulation. Here's another one. Maybe it's something you haven't thought about, but you can even think about hair growth rate, like the way the rate at which your hair grows and its corresponding accumulation. And in this case, the accumulation is going to be, it says inches of hair. So likewise, we're going to go ahead and try to connect the big ideas with these 2 graphs. So when you're making your sketch of this, again, it's just basic sketch of this hair rate. Just going to do the X and Y. You're going to do a horizontal line at the Y value of 1. You want to make sure you include your rate. So this is going to be inches of hair per month. That's the rate. And over time, it's months here. The accumulation is just inches of hair, and then the time is months. So the time is going to be same. Notice that the hair rate for this particular person is constant. So for this particular person, their hair grows at a rate of 1 inch per month. And over time, like for example, let's just say they started off bald. After 1 month, they have 1 inch of hair. 2 months, they have 2 inches. 3 months, 3 inches. So see how the hair gets accumulated. That's why it's called accumulation graph. So hopefully as I'm talking, you all get to sketch or do your sketches down. Let's go ahead and try to verify the big ideas once more so it can doubly stick to y'all. So again, I'm going to take a look at the first 2 months. So I'm going to shade the area under the rate graph for the first 2 months. So it's like a horizontal rectangle. And I'm just going to shade this in. And if I remember my big ideas, the big idea is if I find the area of the shaded rectangle, it should give me the accumulated unit, which is total inches of hair. That's what should happen. So let's try to find the area of this here rectangle. The height of this rectangle is 1 inch of hair per month. I have to remember the rate too. So the height is 1 inch. I'm just going to say inch per month. Per month. And the base of this rectangle is going to be 2 months. All right, so basically to find the area of the rectangle, I'm going to do base times height, or you could do height times base. Either way, you should get the answer. In order for me to match up our big ideas, of course, I'm going to first do the rate because I want to connect again the rate times time is equal to the accumulated unit. Again, I just definitely want to stress this. I'm just going to put accu unit. So my rate here is the thing that has per. So I'm going to do inch per month. 1 inch per month. That's my rate. Times 2 months. Again, a unit will cancel out. And it's usually the unit that's the same. So in this case, it's months. So we are going to cancel out months. We're going to get that after 2 months, it looks like we're going to have 1 times 2, so 2 inches of hair. Inches of hair. It's messy, but you know, I should say inches of hair. And again, that's because the area of the rectangle gives me that accumulated unit, or you can think of it as rate times time gives me accumulated unit. Again, if we go back over here, after 2 months and we try to verify, do I indeed have 2 inches of hair? You will see that yes, we do end up having 2 inches of hair after 2 months. So boom. And again, you can verify the slope of the accumulation. It's going to be 2 divided by 2. That's going to give you 1, which is that 1 inch rate. So 2 inches divided by 2 months. My slope. That equals 1 inch per month, which is the rate. And I know it's very messy how I'm writing. So the slope gives me the rate graph. And again, the area of the rate graph gives me accumulation. There we go. Such a workout to write these things with the tool. Oh, that's okay. So someone says they're worried that they won't be able to get it by 2. That's fine. Take your time. I think I put the deadline as by midnight tonight. So y'all just need to turn in your notes by midnight tonight. So don't worry about the time so much, y'all. Definitely. And I could also send the video as well. All right, let me go ahead and pause here. And then right after this is going to be our Google form. The Google form is not on accuracy. It's basically just for me getting down what y'all understood from these notes. And it's just based on credit, like participating credit, not like whether you're right or wrong. You'll see. So let me just first give you all a minute on this slide, and then we'll get to the Google form. All right, y'all. Hopefully, you at least got at least the gist of this one here down. Again, but that's just the main ideas here. Again, we're at the beginning where the area under the rate graph gives you accumulation, whatever is being accumulated, whether it be hair, money, distance. You could apply this to anything. And then usually the slope of the accumulation graph gives you back that the rate graph. Those are just like the highlights of our big ideas. And again, they're going to lead us throughout this unit, even through our next mini final, which will be later on, but you'll see. All right, so for the Google form, we'll have 10 minutes. Let me go ahead and get this to y'all. I'm going to put it in the chat, and I'm going to open it along with you so that y'all understand what's on there. Here's the Google form. And on the Google form, again, it's not based on accuracy. It's just your participation. You're going to put your email address. The first question says, in your own words, describe how is the accumulation graph related to the corresponding rate graph? And you're just going to type out your answer. That's in your own words. Like, what did you understand from the big ideas? Number two, you have this different kind of, it's a pay rate graph. And notice that the pay rate here is at a constant $10 per hour. And I'm asking you to explain how would you use the area under rate graph to determine how much money you earn after 5 hours. And this, it's okay if you're like still stuck on it. Just try your best. I just want to know where you're at. Then number three, I give you an accumulation graph, and then I ask you to try to explain how you would use a big idea to determine the rate. And remember, the big ideas are right here up for you. There are 3 big ideas. And then lastly, I would like to know any questions that you have about today's lesson. Then you're going to hit submit. This will also be graded for participation. Let me know if anyone has any questions about the Google quiz. Sorry, Google form checkout. And no, it's not the end of class after this 10 minutes. We still have one more thing to do, by the way, after, I think, maybe. All right, if there are no questions, let's go on with this exit ticket from the Desmos activity. Let's have 10 minutes. Good luck, everybody. I'll be here. I'm just gonna turn off my camera, but just unmute yourself, or you could text something in the chat. All right, see you in about 10 minutes. All right, everybody. So if you are still like trying to answer the Google form exit ticket, please take your time on doing that. But you want to make sure you hit submit so that you get your credit for today on that. You definitely want to like hit submit on that. But let's go ahead and take you all into the checkout question. So let me just get out of here. So for our next class, we're going to take a look at a curvy rate graph. So something that looks like this. And this is like a heart rate and beats per minute. As you all know, when we're walking or running, our heartbeat is not at a constant rate. It changes, you know, depending if we get worked up or if we're doing exercises. So for our next class, just be prepared. We're going to take a look at what happens when the rate graph is curvy, because we're looking at a bunch of horizontally straight constant rate graphs. All right, so here we go. Here's our checkout question, everybody. As you were answering the checkout, don't forget we also have those notes that are also due. So we have the notes that are due. Make sure you upload those as well. But our checkout is: what questions or understandings do you have about today's lesson? And then once you answer that checkout, you're free to log on out, and you all have a good day. All right, but I definitely want to know, what understandings or questions do you have about today's lessons? All right, I understand the relationship between the graphs. That is deep. That rate times time equals accumulated unit. Yes, and I hope I see that in the mini final when you talk about using all these vocabulary words. A good question here being asked is, why do we need both graphs? That's a good question. More on the accumulated graphs and how do you get the total result? I know how, like, maybe if you have a rate, how do you get the accumulation? I understand that each piece of the graph is important. Oh, using the vocab words might take a while. That's okay. I understand how to use rise over run for accumulation graphs.
Wait, do we comment that on the thing? And that's our exit, our checkout? I'm
So
so sorry
yeah,
for cooking.
our checkout is, yeah, you're gonna use the chat box to go ahead and answer that. Yes, but I put that. You answered it. You put the vocab one. I understand. Okay, the x-axis for both graphs usually cross each other out. Oh, that's nice, CJ. That's nice. I actually did not know that, but that's true. And when you multiply the rate times time, the x-axis units are the things that are canceling out. That's key right there. Understanding I have is the accumulated graph is constant rate of the rate graph. Rate equals slope, I think. Yes. All right, y'all. These were awesome. Thank you so much for sharing. And I hope you all have a great day. The relationship between each graph and the function knowledge needed for the constant rate and accumulated numbers. Awesome, Gabriel. Awesome. All right, y'all. Y'all have a great day. Good evening. Don't forget to turn in your notes. I'll see you all soon.
All right, then.
Bye. Bye, y'all. Bye, CJ.